The AI war does not really start inside a chatbot. It does not start with a demo on a stage. It does not start with a clever prompt. It does not start with a glossy product launch where everyone claps because a machine wrote a poem, drew a picture, or summarized a meeting. The real AI war starts in a place most users will never see. A data center, a building with no romance from the outside, a fenced campus, security gates, loading docks, concrete, steel, fiber lines, power equipment, cooling systems, rows of machines running so hot and so hard that the whole building feels less like an office and more like an industrial plant. Inside those buildings is the new battlefield of technology, because every answer has to run somewhere. Every coding suggestion has to run somewhere. Every AI image, every generated video, every customer service agent, every enterprise co-pilot, every voice bot, every recommendation model, every research assistant. Every automated workflow has to run on real machines using real electricity. That looks like software to the user. But behind the screen, AI is becoming one of the most physical businesses on Earth. It needs chips. It needs power. It needs cooling. It needs land. It needs fiber. It needs servers. It needs financing. It needs construction crews. It needs supply chains that stretch across the world. That is why the most important AI question may not be who is the smartest. The bigger question is who has enough cloud power to run the future. That is the war Microsoft, Amazon, Google, Oracle, Meta, Nvidia, CoreWeave, OpenAI, Anthropic, xAI, and half the technology industry are now fighting. It is not a normal cloud competition anymore. It is a fight over the factory floor of artificial intelligence, and the bill is climbing toward numbers that almost stop sounding real. Hundreds of billions, then more again. This is the trillion-dollar war for AI cloud power. For years, people talked about the cloud as if it was weightless. Your photos were in the cloud. Your files were in the cloud. Your apps were in the cloud. Your backups were in the cloud. The word made it sound soft, clean, and invisible. But the cloud was never in the sky. It was always someone else's computer sitting inside someone else's building, plugged into someone else's power supply. The old cloud was already massive. It ran websites, apps, databases, streaming services, business software, payment systems, and online stores. It made the internet flexible. A startup could launch without buying a server room. A large company could rent capacity instead of building everything itself. Amazon Web Services turned this into one of the greatest business inventions of the modern internet. Microsoft Azure became the enterprise cloud machine. Google Cloud built on Google's infrastructure and data strength. Oracle fought to stay relevant. The cloud changed how software was built, but AI has changed the cloud itself. A normal website might need ordinary servers. A normal database might need storage and CPS. A normal business app might stale with predictable patterns. AI is different. Large models need specialized chips. They need high-speed networking. They need huge memory bandwidth. They need dense racks that create enormous heat. They need systems that can move data between thousands of chips without wasting time. They need platforms that can train, fine-tune, serve, monitor, and secure models. This is not just renting a server. This is renting a piece of a supercomputer. And when millions of people start using AI tools at the same time, the supercomputer has to keep expanding. That is why the cloud has gone from a utility to a strategic weapon. In the first internet era, companies fought, but they also fight for capacity. The company with capacity can serve customers. The company without capacity waits. And in technology, waiting can be fatal. The strange thing about this war is that the public sees only the front stage. People see ChatGPT answering a question. They see Gemini writing an email. They see Claude summarizing a document. They see Copilot completing code. They see an AI image appear in seconds. It feels instant. But every instant answer has a cost behind it. Somewhere, a chip is working. Somewhere, memory is moving data. Somewhere, a cooling system is pulling heat away. Somewhere, a cloud platform is routing the request, checking permissions, logging usage, and sending the result back. If the answer feels magical, it is because the infrastructure is hidden. That hidden layer is where the money is going. Microsoft has described a huge global data center footprint with more than sitting data centers across key regions and more than 2 gigawatts of new capacity added in 1 year. Amazon has recorded massive cash capital expenditures tied largely to technology infrastructure supporting AWS growth and said those investments are expected to rise. Alphabet has said it invested heavily in technical infrastructure and expects to significantly increase spending on servers, networking equipment, and data centers. Nvidia has reported explosive data center demand and record revenue as AI chips became one of the most important products in the world. These are not just accounting details. They are signs of a historic build-out. The AI race has moved from the demo stage to the construction stage. That shift matters because construction is slower than software. A model can improve in months. A startup can launch in weeks. A viral app can appear overnight. A data center cannot. You need land, you need permits, you need power, you need chips, you need networking gear, you need cooling systems. You need engineers. You need construction timelines. You need local approval. Software wants to move fast. Infrastructure moves at the speed of physical reality. That gap is where scarcity appears, and scarcity is where power lies. The first player to understand is Microsoft. Microsoft entered the AI cloud war with one of the strongest hands in the industry. It had Azure. It had giant enterprise relationships. It had Windows. It had Microsoft Sentinel. It had Teams. It had GitHub. It had security products. It had decades of trust with CIOs. And then it had the relationship that changed the entire story, OpenAI. When ChatGPT exploded into public life, Microsoft suddenly looked like the company with the most direct path to commercializing frontier AI. This was not only about putting a chatbot on the internet. Microsoft could put AI inside Word, Excel, PowerPoint, Outlook, Teams, GitHub, Dynamics, Azure, security tools, and the daily workflow of huge companies. That is Microsoft's superpower. It does not need to drag customers into a totally new world. It can say, you already work here. Now the AI works here too. A lawyer writing in Word, a finance team modeling in Excel, a developer coding in GitHub, a sales team living in Teams and CRM, a manager buried in emails, an enterprise already paying Microsoft every year. Microsoft can attach AI to all of it, but that dream creates an infrastructure nightmare. Every Copilot request needs compute. Every coding suggestion needs compute. Every enterprise agent needs compute. Every OpenAI workload needs compute. Every business customer experimenting with AI increases pressure on Azure. If Microsoft wants AI to become the new layer of work, it has to build the cloud underneath that layer. That is why its data center language has become so important. AI-first regions, liquid cooling, new capacity, how they will scale. The product strategy depends on the physical build-out. Microsoft's bet is simple, and enormous enterprise AI demand will be so large that today's infrastructure spending will look obvious later. If that bet is right, Azure becomes one of the key operating systems of the AI economy. If it is wrong, investors will ask why so much money was spent before the revenue fully arrived. Then there is Amazon. Amazon Web Services built the modern cloud business. For a long time, AWS was the name people used when they talked about cloud infrastructure. It was the place startups built. It was the engine behind thousands of companies. It had storage, compute, databases, security, analytics, and more services than most people could remember. AWS was not just a business line. It was one of the great profit engines of the technology industry. But the first wave of public AI excitement created a strange moment for Amazon. Microsoft had OpenAI. Google had DeepMind and Gemini. Nvidia had the chips. OpenAI had the public mint share. Afterpick was rising. Startups were everywhere. People started asking an uncomfortable question. Was AWS behind an AI? That question may have been too simple, but perception matters. Amazon's answer has been to make the AI cloud war about choice, infrastructure, and custom chips. AWS has its own AI chips, including Train IUM for training and Inferent IA for inference. It is Bedrock, which lets customers access different foundation models. It has a major partnership with Anthropic. It has a massive customer base that already trusts AWS for serious infrastructure. Amazon's pitch is not one famous chatbot. Amazon's pitch is, bring your AI workload here, choose the model you want, use our tools, use our chips if they help your economics, and build inside the cloud you already know. This fits AWS perfectly. AWS has always been a building block company. Storage block, compute block, database block, analytics block, security block, now AI block. The challenge is that AI requires more spending intensity than traditional cloud. Customers do not just want normal capacity. They want advanced chips, faster networking, better cost controls, private model options, and enough supply when everyone else is also asking for the same thing. Amazon cannot rely on old cloud dominance. It has to prove AWS is still the place to build in the AI era. That is why every large AI's infrastructure commitment matters. A big AI cloud deal is not just revenue. It is a message to the market AWS is still in the fight. Google has the most complicated position of all. In one sense, Google should have owned this era from the beginning. Google had world-class AI research. It had DeepMind. It had the transformer research that helped make modern language models possible. It had huge internal infrastructure. It had data. It had search, YouTube, Android, Chrome, Gmail, Maps, and one of the largest computing operations ever built. Google also had something very important: custom AI chips. TPUs, or tensor processing units, in Google, a way to run AI workloads without depending only on Nvidia GPUs. For years, Google used TPUs internally. That experience matters because custom chips can lower costs, improve performance for specific workloads, and give a company more control over its AI destiny. But Google also had a problem. Google Cloud was smaller than AWS and Azure in enterprise cloud market share. Google had amazing technology, but enterprise cloud is not won by research papers alone. It is won by sales teams, trust, contracts, compliance, support, integration, and long relationships. AI gives Google Cloud a second chance. If companies believe Google has the strongest AI stack, they may bring more workloads to Google Cloud. Gemini can pull customers in. Vertex AI can help developers. They query can connect data to AI. TPS can offer a different economic story. Google's research credibility can become a cloud sales weapon. Google's pitch as we know are because we helped invent the modern AI era. That is powerful. But Google also has enormous internal demand. Search needs AI, YouTube needs AI. Ads need AI. Gemini needs AI. Workspace needs AI. Internal research needs AI. So Google is both a cloud provider and one of the world's largest AI infrastructure consumers. That can be a strength because scale teaches lessons. It can also create pressure because internal and external demand both need capacity. Google cannot afford to lose the AI cloud war because AI threatens and strengthens its core business at the same time. It has to defend search, grow cloud, improve Gemini, support YouTube, and control infrastructure costs. That is a lot of battles for one company. Now we need to talk about Nvidia, because no matter which cloud provider wins, Nvidia has been standing at the center of the battlefield. Nvidia did not just sell chips. It sold the standard equipment for the AI boom. Its GPUs became the default choice for training and running many modern AI models. CUDA became a software moat. Developers learned it. Researchers used it. Frameworks supported it. Data centers were designed around it. Then Nvidia added networking systems and full-stack infrastructure that made it even harder to replace. In a gold rush, the people selling picks and shovels often make the most reliable money. Nvidia became the picks, shovels, engines, and maps of the AI gold rush. When Microsoft builds AI infrastructure, Nvidia often benefits. When Amazon sells Nvidia GPU instances, Nvidia benefits. When Google offers Nvidia hardware alongside TPU, Nvidia benefits. When Oracle signs large AI infrastructure deals, Nvidia often benefits. When CoreWeave grows, Nvidia benefits. When model labs need training clusters, Nvidia benefits. This is why Nvidia's data center revenue became one of the clearest signals of the AI boom. But Nvidia's success creates tension. Its customers need it, but they do not want to depend on it forever. Cloud providers are not sentimental. If one supplier captures too much margin, they look for alternatives. That is why Amazon builds Train IUM and Inferent IA. Google builds TPS. Microsoft Meta has chip efforts. AMD is fighting to compete. Broadcom helps with custom silicon. Startups are trying new architectures. Everyone wants to reduce dependence on Nvidia. But replacing Nvidia is not easy. Performance matters. Software matters. Developer trust matters. Networking matters. Availability matters. A cheaper chip is not enough if the ecosystem is painful. So the likely future is not Nvidia disappearing. The likely future is a mixed world. Nvidia remains central for many high-end workloads. Custom chips run in specific clouds. Inference gets more specialized. Smaller models run on cheaper hardware. Dense devices handle some tasks. The chip market becomes more diverse, but Nvidia stays extremely important. That still means the cloud giants will keep trying to capture more of the stack. The arms dealer is powerful, but the armies want their own weapons factories. Oracle is one of the more surprising characters in this story. For years, Oracle was not the first company people mentioned in the cloud war. AWS, Azure, and Google Cloud got most of the attention. Oracle was a database empire trying to prove it could be a serious cloud infrastructure company. Then AI changed what customers cared about. In the AI cloud war, the question is not always who has the coolest brand. The question is who has capacity. Who can give me the chips? Who can give me the networking? Who can give me the cluster? Who can build fast enough? Who can support a giant AI workload when everyone else is constrained? That question gave Oracle an opening. Oracle leaned into AI infrastructure. It pursued large customers. It positioned its cloud as a place that could handle major AI workloads. It became part of conversations that would have seemed unlikely in the old cloud ranking. This is what platform shifts do. They reopen markets. A company that looked behind in the old race can find a new lane in the new race. CoreWeave is another example, but even more extreme. CoreWeave was not a traditional hyperscaler. It specialized in GPU cloud capacity. For years, that might have sounded niche. Then the world suddenly needed GPS more than almost anything else in technology. GPU scarcity turned specialization into leverage. If you had capacity, you mattered. That is the lesson. In a boom where advanced compute is scarce, capacity itself becomes a product, not a feature, not a slogan, not a dashboard. Capacity, but there is risk. Specialized AI clouds often have expensive hardware, heavy financing needs, and customer concentration. If demand shifts, if the big clouds catch up, if customers build their own infrastructure, or if chip availability changes, the economics can move fast. Infrastructure fortunes can rise quickly. They can also become fragile. That is why this war creates both new giants and new risks. OpenAI and Anthropic are not cloud providers in the traditional sense, but they are some of the most important forces in the cloud war because they create enormous demand. OpenAI turned generative AI into a public habit. ChatGPT made millions of people understand AI in a new way. Suddenly, every enterprise asked about AI strategy. Every startup had to explain its AI plan. Every cloud provider needed a stronger answer. But product demand creates infrastructure demand. If hundreds of millions of people use your AI products, you need huge inference capacity. If you want to train the next generation of models, you need massive clusters. If you want to offer voice, images, video, coding, agents, enterprise tools, and real-time assistance, you need even more compute. This is why model companies become tied to cloud providers. Model labs bring intelligence and user demand. Cloud providers bring capital and capacity. The relationship is powerful, but it is not simple. Model companies want cheap, reliable, Abundant compute. Cloud providers want revenue lock-in and strategic influence. Model companies want independence. Cloud providers do not want to become invisible landlords for someone else's empire. This creates tension. A model lab may start as a customer. Then it becomes a strategic partner. Then it may want its own infrastructure. Then the cloud provider has to decide whether to help control, compete, or head. The future may depend on who captures the most value, the model company or the cloud company. If the best models remain rare and highly differentiated, model labs have enormous power. If models become more interchangeable, cloud infrastructure and distribution become more important. If open models improve quickly, the clouds can sell compute to everyone. If agents become tied deeply to enterprise workflows, platform companies may capture more value than pure model labs. No one knows which layer will dominate, so everyone is trying to own more layers. Cloud companies build models. Model companies seek infrastructure. Chip companies build systems. Software companies build agents. Data companies build data platforms. The whole stack is collapsing into one giant fight. To understand the money, you need to understand the words training and inference. Training is when a model learns. It is the expensive, amatic part people talk about when they imagine huge clusters of GPS running for weeks or months. Training creates the model. It is where labs spend enormous amounts of money trying to improve capability. Inference is when the model is used. Every question you ask your chatbot is inference. Every image request is inference. Every coding suggestion is inference. Every I search answer is inference. Every voice agent response is inference. Every enterprise workflow step that calls a model is inference. In the early AI boom, training got most of the glamour. But inference may become the bigger business. Training builds the engine. Inference is every mile driven. If AI becomes part of daily work, inference demand could explode. A single AI agent may call models many times to complete one's asked. Plan, write, check, revise, call a tool, read the result, and respond. One user request can become many compute events. This is why cloud providers care so much about inference cost. If inference is too expensive, many AI business models break. They free consumer app to not spend too much per answer. An enterprise agent must save more money than it costs. A coding assistant must justify its subscription. An AI search engine must find a way to pay for answers. The industry has to make intelligence cheaper. That is why custom chips matter. Smaller models matter. Routing matters, caching matters. Quantization matters. Distillation matters, model optimization matters. Better data center design matter. The winner is not simply the company with the most raw compute. The winner may be the company with the lowest cost per useful answer. That phrase is boring, but it may decide the entire AI economy. Raw power gets headline. Unit economics decides survival. Power is the least glamorous part of the story, but maybe the most important. AI chips consume electricity, and a lot of it. A data center needs power not only for servers, but also for cooling, networking, storage, and backup systems. AI data centers can be denser and more demanding than older facilities. As clusters grow, power availability becomes a competitive advantage. This is why cloud companies are not only talking to chip makers, they are talking to utilities, energy developers, regulators, local governments, nuclear companies, renewable developers, and anyone who can help them secure reliable electricity. The AI cloud war has made electricity strategic. That sounds strange if you think AI is just software. But once you understand the infrastructure, it is obvious. A model cannot run on hype. It runs on power. This brings geography back into technology. For years, the internet made people feel like location mattered less. You could build a software company from anywhere. Your app could reach the world. AI infrastructure reminds us that location still matters. Where is land available? Where is power cheap? Where can permits move quickly? Where is water available for cooling, or where can liquid cooling reduce pressure? Where is fiber access strong? Where are the customers? Where are the tax incentives? Where is the political support? Northern Virginia, Texas, Arizona, Ohio, Oregon, Iowa, Georgia, Ireland, Finland. Singapore, Japan, the Middle East, and many other regions are part of the new AI map. Data centers are becoming the oil fields of the intelligence economy. Except the resource is not underground. The resource is power, connectivity, chips, and construction speed. Communities will not always welcome this quietly. Data centers can bring tax revenue and jobs, Emil, but they can also raise concerns about water, land, noise, grid stress, and electricity prices. So the AI cloud war will not be fought only in Silicon Valley. It will be fought in local planning meetings, energy markets, and power grid negotiations. There is a very old-fashioned reason this war is so dangerous: capital expenditure. For years, big software companies were loved because they could scale without building factories everywhere. Software had beautiful margins. And another user, sell another subscription, deliver another digital product, and the cost often rose slowly compared with revenue. AI is changing that story. AI at scale demands physical investment: servers, chips, buildings, cooling, power, networking, land, long-term contracts, financing. These costs arrive before the future revenue is fully proven. That is why investors are both excited and nervous. The optimistic story is clear. They will become part of every business. Demand will exceed supply. Cloud providers that build early will capture huge recurring revenue. Agents will increase usage. Enterprise AI will become a standard budget item. Consumer AI will become a daily habit. The skeptical story is also clear. Companies may be overbuilding. Customers may not pay enough. AI tools may not produce enough return. Inference costs may squeeze margins. Efficiency improvements may reduce the need for some capacity. Older chips may lose value quickly. Power constraints may slow deployment. Some AI revenue may be hype. Both stories have evidence. That is why the war is so fascinating. A data center is not a viral app. You cannot pivot it easily. You cannot move it casually. You cannot undo a giant power commitment overnight. You cannot make a half-built campus disappear from the balance sheet. Infrastructure is a bet with concrete attached. If the bet works, the payoff can last for years. If it fails, the mistake is expensive. This is why every earnings call now matters. CapEx guidance is no longer a boring finance line. It is the scorecard of the aeon's race. The future of AI is being written in capital spending plan. The chip war inside the cloud war is its own drama. At the center is a simple problem: everyone wants the best AI chips, and there are not enough perfect substitutes. Nvidia built the dominant position, but the cloud giants hate being dependent on a single supplier. Dependence means weaker margins, supply risk, and less control over the roadmap. So they build their own chips. Amazon wants Trainiu and an inferent IA to reduce costs for training and inference. Google wants TPS to give customers and internal teams an alternative. Microsoft has developed Maya. Meta has internal chip efforts. Others are working on specialized silicon. This is not just engineering pride. It is business survival. If a cloud provider can run inference cheaper on its own chips, it can lower prices, improve margin, or both. If it can train models efficiently without waiting for Nvidia supply, it gains strategic freedom. If customers trust the custom chips, the cloud provider becomes less vulnerable. But custom chips are hard. A chip is not useful by itself. It needs software. It needs developer support. It needs compatibility. It needs reliability. It needs a reason customers will change behavior. Nvidia's node is not only hardware, it is the whole ecosystem. That is why the custom chip fight will take years. The likely future is not one winner. It is workload specialization. Nvidia formed any cutting-edge training and high-performance workloads. TPS for Google-optimized AI. Trainiu and an inferent AI for AWS customers seeking cost efficiency. Maya for Microsoft workloads, OND in certain deployments, specialized chips for inference, edge, and private AI. The chip mix becomes part of cloud strategy. Customers may not care which chip runs their workload if performance, cost, and reliability are good. Cloud providers care deeply because chips determine economics. The war for AI cloud power is also a war for who gets the margin inside every answer. Networking is one of the hidden killers in AI infrastructure. People talk about GPS like each chip is a magic brain. But large AI systems depend on thousands of chips working together. Those chips have to communicate extremely quickly. If the network is too slow, expensive chips sit idle. That is like buying a fleet of race cars and forcing them to drive through city traffic. Training large models requires a bandwidth, low latency connections. Data has to move constantly. Model updates have to synchronize. Storage has to feed the system. The whole cluster has to operate like one giant machine. This is why networking companies, optical links, switches, InfiniBand, Ethernet improvements, and cluster architecture matter. The AI cloud is not just chips in racks. It is a coordinated system. Cooling is another hidden killer. As chips become more powerful, they produce air cooling can become insufficient for dense AI racks. Liquid cooling becomes more important. Data center design changes. Rack density changes. Power delivery changes. Maintenance changes. A cloud provider can have the money to buy chips and still struggle to deploy them if power and cooling are not ready. This is why data centers are not ordinary warehouses. They are specialized industrial systems. The public hears about models. The operators worry about heat. The public hears about intelligence. The engineers worry about utilization. The public hears about a new AI assistant. The infrastructure team worries about whether the cluster can handle a usage spike without wasting millions of dollars in idle hardware. This is the real world behind the AI dream. Every beautiful answer depends on ugly engineering problems being solved quietly. The cloud war is also a war for enterprise lock-in. Cloud companies do not only want to rent GPS for one project. They want customers to build their AI future inside their ecosystem. That means data storage, data processing, model access, fine-tuning, security, monitoring, agent frameworks, APIs, billing, governance, and business application. Once all of that is connected, switching becomes painful. If a company builds hundreds of internal agents on Azure, connects them to Microsoft Identity, stores data in Microsoft tools, and integrates everything with Microsoft Sunday, moving away is difficult. If a startup builds its product around AWS services, Bedrock SN security tools, and custom AWS work, switching is difficult. If an AI team builds on Google Cloud with Gemini, Vertex AI, BigQuery, and TPS, switching is difficult. This is not always evil. Deep integration can make products work better. But deep integration is also gravity. Data gravity, workflow gravity, developer gravity, compliance gravity, training gravity, contract gravity. The cloud provider that wins the early architecture decision may earn revenue for years. That is why the AI cloud war is a land grab. Customers think they are choosing tools. Cloud providers know they are choosing foundation. The danger for customers is waking up 5 years later and realizing the company's AI brain is deeply tied to one vendor. The danger for cloud providers is that customers know this and will push for portability. So the next few years will be full of polite language about openness. Open models, open standards, multi-cloud, hybrid cloud, interoperability, customer choice. Some of it will be real. Some of it will be marketing. Because every platform wants to be open enough to attract customers and closed enough to keep them. That tension is the heart of cloud strategy. The customer side of this war is more complicated than people think. A bank does not buy AI cloud like a gaming startup. A hospital does not buy AI cloud like a social media company. A government agency does not buy AI cloud like a video generation app. Different customers care about different things. A model lab wants huge clusters and maximum performance. A bank wants security, compliance, audit logs, and reliability. A startup wants low cost and speed. A government wants sovereignty. A retailer wants personalization and integration with existing systems. A pharmaceutical company may need scientific computing. A law firm may need privacy and document control. A media company may need video generation and rights management. This means AI cloud power is not one product. It is many products. The cloud provider that wins one segment may not win another. AWS may win customers who want broad cloud building blocks and flexibility. Microsoft may win companies already living inside its enterprise software. Google may win AI native data workloads and customers attracted to TPS and Gemini. Oracle may win large AI infrastructure deals where capacity and price are central. Specialized GPU clouds may win training heavy customers who need clusters fast. The market will not be clean. It will be segmented. This is why the war will last. There is no single finish line. The fight for AI cloud power will happen workload by workload, industry by industry, customer by customer. That is how cloud markets work. Big headlines talk about one winner. Real enterprise markets create many layers of winners, but make no mistake, the largest layers will be worth enormous amounts of money. That is why everyone is willing to spend so much now. Now let us talk about the most important business model question. Will AI revenue justify AI infrastructure spending? That is the question investors keep asking. It is not enough for people to use AI. Usage has to turn into money. And that money has to be large enough to pay for chips, data center, power, engineers, depreciation, and the cost of capital. A free chatbot with heavy usage may lose money if there is no strong monetization. A consumer app with viral growth may be expensive to serve. An enterprise a product may have strong revenue but slow adoption. A coding assistant may improve productivity but face competition and pricing pressure. An a search engine may need ads or subscriptions to pay for answers. AI does not escape economics. Someone pays. The user pays through subscription. The enterprise pays through contracts. The advertiser pays through attention. The investor pays through funding losses. The platform pays to defend its ecosystem. The cloud provider pays up front and hopes customers pay later. The best AI businesses will match high-value use cases with efficient compute. The weakest AI businesses will deliver expensive outputs that customers do not value enough. This is why cloud providers care about enterprise AI. Businesses can pay more than consumers if AI saves time, reduces headcount growth, improves sales, lowers risk, or speeds operations. A tool that saves a company millions can support serious cloud spending. A toy that entertains users for free may not. This is why the cloud war is tied to the future of work. If AI becomes digital labor, cloud providers can sell the infrastructure behind that labor. If AI remains a novelty layer, the spending looks far more dangerous. AI agents are the reason cloud executives keep smiling. A chatbot waits for a person to ask something. An agent can keep working. That changes demand. A customer service agent can handle tickets all night. A finance agent can process invoices continuously. A sales agent can research leads, write follow-ups, and update CRM fields. A coding agent can run tests and suggest fixes. A research agent can monitor changes and prepare summaries before anyone opens a laptop. This turns AI from occasional use into constant workload. Cloud companies love constant workload. A human asks one question. An agent may take 20 steps. Each step may call a model, search a database, use a tool, check an output, and revise the plan. That is a lot of inference. So when cloud providers talk about agents, they are not only talking about productivity, they are talking about demand creation. Agents make AI usage deeper. They create more model calls, more data movement, more storage, more monitoring, more security, more governance. That means more cloud revenue if the economics work. This is why every major cloud platform wants agent frameworks inside its ecosystem. Build your agents here. Connect your data here. Use our models. Use our security. Use our monitoring. Use our billing. Use our compute. The agent is the front door. The cloud is the house. If AI agents become the new digital work, cloud providers become the landlords of that work. That may be the biggest business opportunity in the entire iCloud war. Not selling answers, powering work. There is a risk that companies will not understand their AI costs until it is too late. In the early cloud era, many companies got surprised by cloud bills. A team launched something, usage grew, storage piled up, data moved across regions, and the bill became painful. The AI can make this worse. A team adds an AI assistant. Another team adds document summarization. Sales adds automated outreach. Support adds an AI agent. Engineering adds coding tools. Marketing adds content generation. Legal adds contract review. Finance adds invoice extraction. Each tool looks useful. Together, they create a large AI bill. Who is watching the total? Which model is being used for which task? Are teams using expensive frontier models when cheaper models would work? Are agents calling models too many times? Are repeated answers being cached? Are low-value tasks consuming high-value compute? This is why cost management will become a real discipline. Companies will need AI FinOps. They will need dashboards showing token usage, model cost, agent cost, department cost, customer cost, and return on investment. They will ask which AI workflows are profitable and which are just expensive decoration. Cloud providers that help customers control cost may build trust. Cloud providers that benefit from confusion may earn revenue in the short term and resentment in the long term. The best AI cloud platforms will not only sell power, they will help customers use power wisely. Because in the AI era, waste can scale as quickly as productivity. A war for cloud power is also a war for data. A model without business data is a general assistant. A model connected to business data becomes useful. That is why enterprises care so much about where their data lies. Customer records can track sales notes, support tickets, financial data, engineering files, medical records, legal documents, product catalogs, and internal policies all become fuel for AI systems. Cloud providers want to sit next to that data. If your data is already in AWS has an advantage. Identity and workflows live inside Microsoft. Microsoft is an advantage. If your analytics live in BigQuery and your teams use Google tools, Google has an advantage. If your core databases are Oracle, Oracle has an advantage. AI does not remove the importance of data gravity. It increases it. A company may choose a model based on intelligence, but it will choose a platform based on data, security, integration, and governance. This is why the AI cloud war overlaps with the data platform war. Databases, warehouses, data lakes, vector databases, governance tools, identity systems, and analytics pipelines are not boring background services. They are where enterprise AI becomes real. If the data is messy, the AI is weak. If permissions are wrong, the AI is dangerous. If the data is locked inside old systems, the AI cannot help much. So cloud providers are not just selling models. They are selling the path from messy enterprise data to useful AI workflow. That path is valuable, and once a company builds it on one cloud, it becomes very sticky. Security may decide more AI cloud deals than raw model performance. A consumer may try any chatbot that feels fun. A bank cannot. A hospital cannot. A government agency cannot. Large organizations need access control. Audit logs, private deployment, compliance encryption, identity management, monitoring, data loss prevention, and guarantees about where information goes. AI creates new risks. A model might expose sensitive data. An agent might take the wrong action. A prompt injection attack might trick a system. A tool-connected agent might access something it should not. A model output might create legal exposure. A poorly configured system might leak confidential documents. As AI moves from chat to action, security becomes even more important. A chatbot giving a wrong answer is bad. An agent with permissions making a wrong change can be much worse. This is why enterprise AI cloud is not just about intelligence. It is about controlled intelligence. Cloud providers with deep security experience can turn this into an advantage. They can say, use our identity system, our private networking, our compliance controls, our monitoring, our governance, our audit trails. This is one reason big clouds may win serious enterprise workloads even if smaller providers have attractive raw compute. Trust matters when AI touches real business processes. The future of AI cloud will be built as much by security architects as by model researchers. The global politics of AI cloud are impossible to ignore. Compute is becoming a strategic resource. Countries want AI capacity for defense, science, healthcare, education, economic competitiveness, public services, and national security. They do not want to depend completely on foreign clouds or foreign ships. This is why sovereign AI has become a serious idea. Governments want local data centers, local data control, local models, local languages, local compliance, local infrastructure. The United States wants to maintain leadership in advanced chips and AI. China is building its own stack under restrictions. Europe wants more control over data and digital sovereignty. Middle Eastern countries are investing heavily in AI infrastructure. Asian economies are trying to position themselves in the next phase of computing. The AI cloud war is not only a corporate race, it is an industrial policy race. Chip export controls, semiconductor manufacturing, undersea cables, data center regions, energy supply, and cloud contracts all become part of national strategy. This makes the cloud providers more important than ordinary vendors. They become partners in national infrastructure. That gives them opportunity and scrutiny. A country may invite a cloud provider to build regions. It may also demand data controls. It may subsidize power. It may regulate usage. It may push for local jobs. It may worry about foreign dependence. AI infrastructure is becoming too important to be left entirely to market forces. That means the trillion-dollar war will involve governments, whether tech companies like it or not. The environmental debate around AI cloud power is going to get louder. Data centers need electricity. Some cooling systems use water. Large campuses constrain local grids. Communities may ask whether the benefits are worth the cost. Supporters will say, I can help solve major problems. It can improve medicine, speed research, optimize energy systems, reduce waste, improve logistics, personalize education, and make businesses more productive. Critics will ask how much power is being used to generate spam, fake images, low-quality content, automated ads, and convenience features nobody truly needs. Both sides will have examples. This debate is not going away because the infrastructure is visible. A chatbot is easy to ignore. A giant data center near your town is not. Local residents may ask, will this raise electricity prices? Will it use water? Will it create jobs? Will it create noise? Will it pay taxes? Will it strain the grid? Who benefits from the power? Cloud providers will respond with clean energy commitments, water efficiency claims, renewable power deals, nuclear exploration, advanced cooling, and economic development promises. Some communities will welcome the projects. Others will resist. The AI cloud war will become part of local politics. That is another way the digital economy becomes physical. The future of artificial intelligence may depend on whether a town council approves a substation. That sounds ridiculous until you understand the scale of the build-out. There is a possible bubble in this story, and anyone pretending otherwise is selling something. Every major technology boom creates overconfidence. Railroads had bubbles. Electricity had bubbles. Telecom fiber had bubbles. The dot-com era had bubbles. Crypto had bubbles. Cloud had moments of overbuild. OE infrastructure may be no different. Some data centers may be built in the wrong places. Some hardware may become outdated too quickly. Some customers may not use the capacity they reserved. Some AI startups may fail before paying enough cloud bills. Some enterprise pilots may never become production systems. Some investors may discover that AI demand is real but not profitable enough for every company in the chain. That is possible. But bubbles can be strange. The dot-com bubble destroyed many companies, but the internet survived and became larger than ever. The telecom fiber boom burned investors, but the bandwidth later enabled huge businesses. Overbuilding can be financially painful and technologically useful at the same time. The right question is not simply, is there hype? Of course there is hype. The better question is, after the hype clears, who owns useful infrastructure? If AI becomes central to business, the best located, best operated, most efficient AI infrastructure will remain valuable. The weak projects will suffer. The strong foundations will become more important. That is why the cloud giants are willing to risk so much. They are not trying to win a news cycle. They are trying to own the roads of the next economy. Roads are expensive to build. But once everyone needs them, tolls are a beautiful business. One of the most dangerous assumptions in AI is that better models automatically create better businesses. They do not. A model can be amazing and still too expensive to serve. A product can be popular and still lose money on each heavy user. A startup can grow fast and still have terrible gross margins. An enterprise tool can impress executives and still fail when employees do not use it enough. AI turns product managers into economists. They have to ask, how many model calls does this feature require? Which model is good enough? Can we cache the answer? Can we use a smaller model? Can we move some work to the device? Can we batch requests? Can we reduce context length? Can we charge enough? Can we keep quality high while lowering cost? This is why the cloud war matters at the product level. A cloud provider that lowers inference cost can make new products viable. A chip improvement can change startup economics. A cheaper model can open a market. A better routing system can save millions. Infrastructure creates product possibility. The reverse is also true. A product with massive demand can justify infrastructure investment. This is the loop. Better infrastructure enables better products. Better products create more usage. More usage funds better infrastructure. The companies trying to create that loop are the ones spending the most today. If they succeed, the loop becomes a flywheel. If they fail, it becomes a money furnace. The AI cloud war will also change the job market in unexpected ways. People talk about AI replacing office work. But the infrastructure boom creates demand for physical and technical jobs. Data center construction workers, electricians, mechanical engineers, cooling specialists, power grid planners, fiber technicians, security staff, hardware repair teams, cloud reliability engineers, chip designers, networking experts, energy project developers, compliance specialists, AI infrastructure software engineers. The AI economy is not only prompt engineers and model researchers. It needs people who can build and operate enormous machines. This creates a strange split. And they automate some white-collar workflows while creating demand for infrastructure labor. The future of work is not simply less human work. It is different human work, concentrated in different places with different skills. A data center boom can bring local jobs and tax revenue. It can also create local strain. The benefits may not go to the same people whose office jobs are disrupted by AI tools. This is how technological change often works. The gains are real. The distribution is messy. The companies building AI cloud power will tell a growth story. Workers in communities will experience a more complicated story. That tension will shape politics around AI. Let us imagine a future company running on AI cloud power. A customer asks for help at midnight. An AI support agent handles the case. An agent checks whether the refund is allowed. A logistics agent updates the shipment. A sales agent notices the customer may churn and alerts an account manager. A marketing agent updates the customer segment. A reporting agent summarizes the incident for the morning dashboard. The company looks efficient. But behind that one customer interaction, many model calls may have happened. Now multiply that across millions of customers. That is cloud demand. Or imagine a software company where every developer has AI assistants. The assistant writes code, reviews pull requests, runs tests, explains errors, updates documentation, and suggests fixes. That is cloud demand. Imagine a media company producing personalized video ads for thousands of audience segments. That is cloud demand. Imagine a healthcare network using AI to summarize records, assist doctors manage appointments, detect billing issues, and support patients. That is cloud demand. Imagine a school system using AI tutors score students in every subject. That is cloud demand. The trillion-dollar build-out depends on these futures becoming normal. Not one viral demo, normal, daily, embedded. That is the key word. AI must become embedded enough that compute demand becomes as normal as electricity, bandwidth, and storage. That is the bet. There is a quieter war happening inside every cloud provider. The war between capacity and utilization. Capacity is what you build. Utilization is whether customers actually use it. A data center full of expensive AI where is only beautiful if the hardware is busy doing paid work. Idle GPS are painful. Cloud providers must forecast demand. allocate chips, manage customer commitments, balance regions, avoid shortages, avoid waste, and keep margins healthy. This is harder than it sounds. If you reserve too much capacity for one customer and their demand disappoints, you may waste resources. If you do not reserve enough and their product explodes, they may leave or complain. If you deploy capacity in the wrong region, customers may not want it. If you buy too much of one chip generation, a better generation may arrive. The AI cloud business is a giant optimization problem, and the variables keep changing. Model sizes change. Inference patterns change. Customer usage changes. Chip performance changes. Energy prices change. Regulations change. Competitors change prices. New use cases appear. This is why operational excellence matters. The winner is not just the company that can spend. It is the company that can spend, deploy, price, route, and optimize better than rivals. Anyone can announce a big number. Not everyone can turn that number into profitable capacity. Now look at the war from the point of view of a startup founder. You are building an AI product, maybe an agent for lawyers, maybe a video tool, maybe a coding assistant, maybe an AI search product. Users love it, growth is exciting. Then the cloud bill arrives. Suddenly, the business looks different. Every user is not just a user. Every user is compute demand. Every feature has a cost. Every long conversation costs money. Every image costs money. Every video costs more. Every agent step multiplies usage. You start asking questions. Can we use a smaller model? Can we test this? Can we limit free users? Can we charge more? Can we negotiate with the cloud provider? Can we move workloads? Can we find an open model? Can we build our own inference stack? Can we survive if API prices change? This is the new startup reality. In the old SaaS world, software gross margins could be beautiful. In the AI world, gross margins can be eaten by compute. That does not mean AI startups are bad business. It means they must be designed carefully. The best AI startups will understand infrastructure economics early. The worst will grow themselves into a cost crisis. This gives cloud providers leverage. They can offer credits, capacity, and technical help. A startup takes the help. It builds on the platform. Later, switching is hard. Cloud credits are not charity. They are ecosystem strategy. The future of search, advertising, and intent also depends on AI cloud power. AI search answers are more expensive than traditional links. AI-generated ads require compute. Personalized shopping assistants require compute. Recommendation systems require compute. AI video ads require compute. Automated creative testing requires compute. The companies that monetize attention are becoming compute companies. Google needs AI for search, ads, YouTube, workspace, and cloud. Meet needs AI for feeds, ads, content creation, messaging, and devices. Amazon needs AI for shopping, ads, logistics, recommendations, and AWS. TIKOK and other platforms need AI for recommendation and tools. Advertising may become one of the biggest hidden drivers of AI infrastructure. A small improvement in ad targeting or creative generation can be worth billions at platform scale. That justifies compute. This is why AI infrastructure is not only about model labs and enterprise copilots. It is about protecting the profit engines of the internet. If AI makes ads more effective, platforms will spend heavily. If AI search changes how users make purchase decisions, advertising markets will shift. If AI agents start buying things for users, the platform controlling the agent may control commercial intent. That is worth fighting for. The cloud war is connected to the ad war, the search war, and the agent war. They are all pieces of the same future. The AI cloud war is full of strange partnerships. Competitors buy from each other. Customers become rivals. Suppliers move up the stack. Cloud providers invest in model labs. Model labs seek infrastructure independence. Chip companies sell to everyone while building more complete systems. This is why the word "deaf," our enemy, describes the market perfectly. Microsoft partners with OpenAI, but also builds its own AI products. Amazon partners with Anthropic while building its own AI stack. Google offers its own models and competes for cloud workloads. Nvidia sells to all the clouds, while cloud providers build custom chips to reduce dependence on Nvidia. Cowie buys Nvidia hardware and competes with hyperscalers for AI workloads. Enterprises want cloud AI but fear lock-in. Everyone needs everyone. Everyone fears everyone. This creates a market that is cooperative and hostile at the same time. The reason is simple. The stack is too big for one company to own easily, but too valuable for any company to ignore. Chips, clouds, models, data, agents, apps, and users are all connected. Every company wants to move into the layer above and protect the layer below. Nvidia moves from chips to systems and software. Clouds move from infrastructure to models and agents. Model lands move toward applications and infrastructure. Software companies move into AI platforms. Data companies move into model workflows. The walls between categories are collapsing. That makes the war unpredictable. One of the biggest misconceptions is that cloud power is only about scale. Scale matters, but timing matters too. Having capacity at the right time can win customers. Having the wrong capacity too early can waste money. Having the right chip slate can still lose the deal. Building in the wrong region can reduce demand. Missing a hardware generation can hurt performance. Timing is brutal. A cloud provider has to make decisions years before demand is fully visible. Should we buy more Nvidia chips now or wait for the next generation? Should we build this data center before power contracts are perfect? Should we design for liquid cooling now? Should we reserve capacity for one large customer or spread it across many? Should we invest in custom chips before customers ask for them? No answer is risk-free. This is why the AI cloud war is a leadership test. The CEOs and infrastructure chiefs are making bets under uncertainty at a scale that can change company history. If they are bold and right, they become heroes. If they are bold and wrong, they burn capital. If they are cautious and demand explodes, they fall behind. If they are cautious and the market's lows, they look disciplined. The same decision can look genius or foolish depending on what happens later. That is why nobody truly knows who is right yet. The winners of the AI cloud war will be obvious only in hindsight. Let us talk about the phrase nobody in tech likes to hear: depreciation. A data center building can last a long time. Power infrastructure can last a long time. Land can hold value, but AI servers and chips can age quickly. When a new chip generation arrives, older hardware may still be useful, but it may not be the best. Customers may want the latest performance. Training runs may move to newer clusters. Inference may shift to more efficient chips. This creates financial pressure. If a company spends billions on hardware, it has to earn enough revenue before the hardware becomes less competitive. The faster the chip cycle, the harder the business. This is why utilization matters so much. A GPU sitting idle is not only wasting electricity, it is wasting time before depreciation catches up. Cloud providers must keep expensive hardware busy. That sounds simple. It is not. Demand changes. Customers delay projects. Software bugs reduce performance. Data pipelines break. New models need different memory. Regions vary. Some workloads need reserved clusters. Others can use flexible capacity. The cloud provider has to match supply and demand across a giant moving system. This is where the industrial nature of AI becomes clear. The magic of AI is built on asset management. That is not glamorous, but it is where profits are made or lost. There is also a future where AI cloud becomes more like a utility. Today, access to advanced compute feels strategic and scarce. Over time, parts of AI compute may become more standardized, cheaper, and widely available. If that happens, raw compute may become less differentiated. The value moves upward to model platforms, enterprise integration, security, data governance, developer tools, cost optimization, user interfaces. This is what happened in parts of cloud computing already. Basic compute and storage became more competitive. Higher level services created lock-in and margin. They may follow the same path. The world fights over GPS. Later, the world fights over who makes those GPS useful for real business. That does not mean infrastructure stops mattering. Utilities still matter. Electricity is a utility, but power companies are still important. It means the profit pools may shift. Cloud providers know this. That is why they do not want to be only landlords for chips. They want to provide AI platforms, agents, security, data tools, and business application. They want to move from compute provider to intelligence operating system. That is the real ambition. Own the infrastructure, then own the workflow. That is how the cloud becomes power. Regulators are going to pay attention. When a few companies control essential infrastructure, governments eventually ask questions. Do cloud providers have too much power over AI startups? Are they favoring their own models? Are they using partnerships to control the market? Are customers locked in? Are cloud contracts fair? Are data center projects stressing public resources? Are foreign companies controlling national AI capacity? Are advanced chips being used safely? These questions are not theoretical. AI touches competition policy, national security, energy policy, labor markets, copyright, privacy, and consumer protection. Cloud providers may become gatekeepers of powerful AI. If training frontier models requires massive compute and only a few clouds can supply it, those clouds become control points. Governments may use cloud providers to monitor large training runs, enforce safety rules, or restrict access to certain capabilities. Some people will support this. Others will argue it centralizes power and hurts open innovation. Either way, cloud infrastructure will not stay politically neutral. The more important AI becomes, the more political its infrastructure becomes. That is why this war cannot be understood only as a market race. It is also a governance problem. Now let us imagine what failure looks like for a cloud giant. It does not necessarily look like bankruptcy. These companies are too large and diversified for simple endings. Failure may look like losing the highest value AI workload. A cloud provider could remain huge in ordinary cloud but fail to become the preferred place for frontier AI. It could sell storage and databases but miss the agent platform. It could spend heavily but see usage flow to competitors. It could build capacity that customers do not want at the price required. That is the subtle failure, not death. Strategic decline. In platform shifts, companies do not always disappear. Sometimes they become less central. That is what every giant fears. Microsoft does not want Azure to be infrastructure for yesterday's software while AI workloads move elsewhere. Amazon does not want AWS to lose the next generation of startups and enterprise AI. Google does not want its research strength to fail as a cloud business. Oracle does not want its AI infrastructure moment to fade. Nvidia does not want custom chips to erode its centrality. Everyone is fighting to remain central. Centrality is the prize. If you are central, others build around you. If others build around you, you capture value. If you lose centrality, you may still be big, but the future happens somewhere else. That is what this war is really about. The most exciting version of the future is that AI cloud power becomes abundant, cheap enough to unlock enormous value. Doctors get better tools. Students get personal tutors. Scientists run more experiments. Small businesses automate boring work. Creators produce at higher quality. Engineers build faster. Governments deliver better services. People get access to knowledge in their own language. New companies are born. That future requires infrastructure. The frightening version is that AI cloud power becomes concentrated, expensive, environmentally controversial, and controlled by a few platforms that decide who gets access and at what price. That future also begins with infrastructure. The technology is not destiny. The business models, regulations, competition, public pressure, and customer choices will shape the outcome. But one thing is clear. AI does not scale without cloud power. The companies building that power are not just supporting AI. They are shaping what AI can become. That is why the data center is the real battlefield. It is where ambition becomes capacity. It is where promises meet power bills. It is where strategy becomes concrete. It is where the future is either built or delayed. At the AI economy looks simple. A person asks a question. The machine answers. But below that surface is a chain of business decisions so large it reshapes the technology industry. A cloud provider decides to spend billions. A chip company ramps production. A utility negotiates power. A data center campus breaks ground. A model lab reserves capacity. An enterprise signs a contract. A startup takes cloud credits. The government debates sovereignty. A community debates water and electricity. An investor calculates return. Then the user sees a sentence appear on a screen. That sentence is the visible tip of a massive industrial system. This is the part of AI most people do not see. They see intelligence. They do not see the machines that make it possible. But the machines are where the war is. The models will keep changing. The apps will keep changing. The names on the leaderboard will keep changing. But the need for compute will remain. The company that can provide it cheaply, reliably, securely, and at massive scale will have power. Power over AI products. Power over startups. Power over enterprise adoption. Power over pricing. Power over the speed of innovation. That is why this war is so important. The future of AI will be written in code, but it will be built in silicon, concrete, copper, feeder water, and electricity. The next decade of business may depend on who controls those foundations. The war has started. The spending has started. The data centers are rising. The chips are being ordered. The power deals are being signed. The customers are experimenting. The investors are watching. And somewhere in a building most people will never see, the future is already running hot.